Hello everyone, and welcome to the show. Today is July 25th, 2026, and it is a wonderful Saturday. I am your host, San Noani, and I am so excited to be here with you today. I hope you are all having a fantastic weekend so far. I am introducing a trending article from the arXiv, and it is a really fascinating one. The title is Code Division Modulation Layers, Ethics for Getting an Inference in Continual Gait Identification. The code is tax:/arXiv.org/abs/260 7.19122v1. It is long, but do not worry, I am going to break it down and make it super easy and fun to understand. So let us dive right into the amazing world of this research. First of all, let me explain in detail the big problem that this paper is trying to solve. Have you ever studied really hard for a math test? But then, when you start studying for history, you completely forget all the math you just learned? No. Well, believe it or not, artificial intelligence has the exact same problem. This is something scientists call catastrophic forgetting. In the world of machine learning, especially with something called continual learning, the AI learns new things step by step. But as it learns main information, this paper specifically looks at systems that identify you by the way you walk, which is called gait identification. And there's smart finance sensors inside it that can feel how you step, how your hips move, and your overall walking rhythm. Because everyone walks a little differently, your phone can use this walking style as a biological password. But since the way we walk can change over time based on what shoes we wear or if we are tired, the AI needs to constantly update itself. That is where the second major problem comes in, which is privacy. When you update the AI on your phone, sometimes it has to send data back and forth. Hackers can use very sneaky methods called membership inference attacks to peek into the AI. They try to figure out if a specific walking data was used to train the model. If they figure that out, your private biological data is compromised, and that is super scary. So, this paper introduces a super clever solution called a code division modulation layer. Let us compare this new technology with other older technologies to see why it is so special. And in the past, to stop the AI from forgetting, scientists would just keep a copy of your old walking data. Walking data. They would mix the old data with the new data and teach the AI all over again. This is called a replay strategy. The problem with replay is that keeping your old data lying in mind is a huge privacy risk. Another older technology is adding extra adapter layers to the neural network. While that stops the forgetting without keeping the old data, it takes up a lot of memory. It might be simple, but this new code division modulation layer works entirely differently. It creates a unique, random mathematical code for every new learning task. It is kind of like giving each memory a completely different radio frequency. So, when the AI learns your new walking style, it scrambles the data using this special code. Because every memory is stored on a different frequency, the new memories never overwrite the old ones. This solves the catastrophic forgetting problem beautifully. And for privacy, it is even better, because everything is scrambled with a secret code. The hackers cannot perform their inference attacks. Even if they look at the AI, it just looks like random noise to them, meaning your attack success rate drops to 50%, which means they are just guessing. Plus, instead of sending huge files, this new method only needs to send a tiny 4-byte seed to create the secret code. That is incredibly efficient with super safe. Now let us talk about how this amazing technology can be applied to our everyday lives. I will give you 3 specific application examples based on the content of this paper. The first specific application is ultra-secure smartphone unlocking. Right now, we use our fingerprints or our faces to unlock our phones. But what if your hands are wet or you are wearing a mask? With this technology, your phone will recognize it is you just by being in your pocket while you walk. Ah? Because the system uses continual learning, it will adapt if you get a leg injury or start wearing high heels. And thanks to the modulation layer, your walking data never leaves your phone in a vulnerable state. Your privacy is completely protected from hackers, making this the ultimate secure lock for your digital life. The second specific application is for smart wearable devices in elderly care. Imagine smartwatches are fitness trackers worn by older adults in a care facility. These devices can constantly monitor their walking patterns to detect if they are becoming frail or if they are at risk of falling. As the patient's age, their gait naturally changes, so the AI needs to continually update without forgetting their baseline health. Health data is incredibly sensitive and private, protected by strict medical laws. By using the concepts discussed in this paper, the care facility can update the health models on the cloud without ever exposing the actual walking data of the elderly patients. This means doctors get the accurate, updated information they need to prevent falls, while the patients keep their medical data completely anonymous and secure. The third specific application is for smart corporate building security. Instead of employees needing to swipe a badge or scan an ID card to appear into different parts of an office building, the building itself can recognize their walking style through floor sensors or wearable company tags. As the company hires new employees, the security system needs to learn new walking styles without forgetting the old employees. With traditional systems, adding new people might cause the system to forget the CEO, which would be super awkward. But with this new modulation code technology, the system can add new groups of employees flawlessly. Furthermore, different security levels can be granted by sharing different modulating codes. Unauthorized guards would have the code to access the specific employee recognition data, meaning regular workers cannot snoop on him into the building and win. It creates a seamless, badge-free security system that respects worker privacy. It is just so cool to think about how these complex math and computer science ideas can directly protect our everyday lives. The researchers really hit a home run with this one, showing that we do not have to choose between a smart AI and a private AI. We can absolutely have both. And it just makes me feel so optimistic about the future of technology and how it will keep us safe. Well, that is all the time we have for today on this deep dive into the archives. Thank you so much for tuning in and listening to my explanations. I hope you found this topic as fascinating and exciting as I did. Please enjoy the rest of your beautiful Saturday and keep smiling. This is Sen No Ani signing off, and I will catch you on the next broadcast.